Yeah, welcome to UC Mathematics and a new video. Today we take again a look at the MIT Integration Bee 2021, the qualifier sheet, and these are from sheet 2. And yeah, the integrals are these: 1 over square root 1 plus e to the x, then e to the power sine x times cosine squared minus sine, and the last one is from minus pi to pi over floor of sine of 2x. And I want to make some recalls. We will not prove them, but we will use them, like the product rule. And the derivative of the inverse hyperbolic tangent is 1 over 1 minus x squared. And then the property of the floor function, it's easy to see on the graph of that. Floor of x plus 1/2 is point symmetric to the origin, so you can think about that. We will use the property 3 obviously for C. And let's start. So the first integral, I would try a substitution, and we substitute the whole denominator, 1 plus e to the power x. So we have x is t squared minus 1, so t squared minus 1. Alright, and then dx becomes 1 over t squared minus 1 times 2t dt. Okay? So the derivative of the natural log is 1 over, and then with the chain rule 2t. Alright? So the integral becomes, so the first one, a, this integral becomes 1 over the square root, and the square root is t, and dx is 2t over t squared minus 1 dt. So 1t goes out, and I factor out a minus, so we get minus integral, and the 2 maybe also, 1 over 1 minus t squared. So if we put the minus here, we get minus 1 plus 2 squared. This is exactly this one, okay? And now we see that we can use our recall. So the integral 1 over 1 minus x squared is the inverse hyperbolic tangent. So we have minus 2 times inverse hyperbolic tangent of t plus some constant, and then we put t back, which is the square root, and so we get minus 2 times inverse hyperbolic tangent of 1 plus e to the x square root. Alright? And if you like, there is also, that you can write the inverse hyperbolic tangent in terms of natural logs. So if you see a solution with natural logs, do not worry, this is okay so far. For the next integral, if you have a close look, there is maybe some chain rule here going on, and we will see. So b, we have integral e to the power sine x times cosine squared of x minus e to the sine x times sine of x. And now if you take a close look, I will rewrite this integral and then we can see this. We rewrite that at e to the sine x times cosine x times cosine x, and I use here, I use this brackets, and then plus e to the sine x times sine x is the minus sine x is the derivative of the cosine, so we write that maybe in this way, dx. Yeah, so if we differentiate the cosine, we get minus sine. Okay, and yeah, now we can see that we have here u b prime. Give me a second. Up. Yeah, v prime, here is v, and this is the derivative of e to the sine is e to the sine times then the chain rule cosine, so this is exactly u prime, alright? Yes, so we can use our product rule and we get u times v, so u is e to the sine and v is cosine plus some constant. All right, this is the second integral, the solution. And now we come to the third integral, and yeah, I guess I clean up the board and come back. Now we can go on with the third integral, this floor of the composite sine functions. And yeah, what I want to use is I want to use some symmetry properties, and yeah, like I said, what you can use is the point symmetry of this function, and I want to use the point symmetry because of the symmetric boundaries of the integral. All right. So what we do is this floor, and we add 1/2 and then subtract 1/2, and I already split it up in the integral. And now we can use this property of the point symmetric function. This means that this part becomes 0, and therefore all we have to solve is this easy integral minus integral from minus pi to pi over 1/2 dx. Yeah, and this is an easy exercise. You get minus pi for the third integral. Alright, I hope you liked it. See you next time to some another integrals. Enjoy and bye bye.